Alright, so here's another example of solving rational equations. Uh, I'll have several videos on this. Each problem will have its own video. Check them out. They'll all be a little bit different. I'm trying to hit all the different outcomes that are all the different types of problems you'll come across. So let's go ahead and get started with this one. So the first thing you want to do is you want to look and see if any of the denominators factor. And we can see here all of these denominators here factor. So let's go ahead and do that. So I've got x minus 1 over x minus 2 times x plus 2. Let me draw that 1 a little bit better. Plus x over, and this is going to be what, x minus 2 x plus 1, and that is equal to 2x minus 1 over, and that's going to be x plus 2 x plus 1. Alright, so the next thing we want to do, now that we've got all the denominators factored, is find any restrictions. Now, if none of the denominators factor, then you just go straight to the restrictions. Alright, so what we want to do is we want to see what makes each denominator 0. So we want to look at the different factors we have. We've got an x minus 2, an x plus 2, and an x plus 1. That's the different factors. So for this denominator, notice if we plug 2 in for x, 2 minus 2 is 0. And you can't have 0 in the denominator of a fraction. So one of our restrictions is x cannot equal 2. And then we go to the next different factor, which x plus 2. Well, what do we have to plug in for x to get 0 here? Well, negative 2 plus 2 is 0, so x can't be negative 2. And then we go to the next one, which is the x plus 1. Well, negative 1 plus 1 is 0, so x cannot equal negative 1. And the other way, I mean, those are easy to do. Sometimes they might have a number in front of them. You'll end up with a fraction. If you can't figure out what number to plug in to make it 0, just take them. Just take the different denominators and set them equal to 0 and solve for x. That's all you do. So in this case, we add 2 to both sides, we get x equal 2, subtract 2 to both sides, and then subtract 1 to both sides, and you can see there's your restrictions. So that's another way to do it, but for this problem you didn't really have to do it because it was easy just to know what numbers to plug in. Alright, so the next thing we need to do is we need to get the common denominator, and we're going to multiply each term by the common denominator. Alright, so to do that, you want to look at each different factor, and you want to use that factor the most times it appears in any of the denominators. So let's go through it. So let's look at the x minus 2. In this denominator, the x minus 2 appears 1 time. In this denominator, the x minus 2 appears 1 time. And in this denominator, the x minus 2 appears 0 times. So we use it 1 time. That's the most it appears in one of the denominators, so we use it 1 time. And then we go to the next one. Let's go to x plus 2. Here it appears once. Here it appears 0, and here it appears once. The most times it appears in one of them is 1 time, so we use it 1 time. And then the same thing, x plus 1, here it appears 0, here it appears once, and here it appears once. The most it appears in one of them is 1 time, so we use it 1 time. And that is your common denominator. So what I'm going to do now is I'm going to multiply the common denominator to each term. Alright, so let's see, I'm going to come down here and I'm going to kind of write it up at an angle, because if I wrote it across I wouldn't have enough room to get it on the screen. So I'm going to multiply this common denominator times this term. Okay, plus, and then I multiply it times this one, so that's going to be x plus 2, x minus 2, x plus 1, and that's multiplied times this, x over x minus 2 times x plus 1, and that equals, and then I've got x plus 2, x minus 2, and x plus 1, and I'm gonna multiply it times the last term, 2x minus 1 over x plus 2, x plus 1. Alright, so now I've got the common denominator multiplied to each term. So you can see here the x minus 1's cancel and the x plus 2's cancel, and I'm left with x plus 1 times x minus 1. X plus 1 times x minus 1. And that's going to be plus, and then I've got x minus 2's cancel, x plus 1's cancel, and so I am left with x times x plus 2. This x times x plus 2 equals, and then let's see, x plus 2 cancels, x plus 1 cancels, and I am left with x minus 2 times 2x minus 1. Alright, so now I need to FOIL this out, distribute the x here, and FOIL this out. So here I'm going to get x squared minus 1 plus x squared plus 2x equals, and then this is going to be what, 2x squared, and then I've got that, and then I've got minus x minus 4x, and then plus 2. Okay. Alright, so let's combine like terms. So I get 2x squared plus 2x minus 1 equals 2x squared minus 5x plus 2. Now, you can see that here, if it looks like we might have a quadratic equation to solve, but we don't, because if we subtract 2x squared to both sides, they just both cancel out. So we've got 2x minus 1 equals negative 5x plus 2. Okay. And so then we will add 5x to both sides. We can add 1 to both sides. And so we get 7x equals 3. And then divide both sides by 7. And so that is going to give us x equals 3 over 7. And I don't think I made an arithmetic mistake anywhere, so alright, so I think that's going to be good. Make sure I fold this out right. That's 2x squared, that's going to be negative x, negative 4x plus 2. Alright, so all that looks good. Alright, so we get x equals 3/7, and if you notice the 3/7, that's not one of our restrictions, and so this is our answer. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.